Energy sources to power automobiles. We are the team, the Beakers.
The challenge consisted of building a minicar powered by a circuit, whose main purpose is to supply energy to servo motors. The circuit works throughout a potentiometer, which adjusts the speed of the servo motors, and an LED along with a photoresistor. Once connected to the power, the LED will turn on, shining directly onto the photoresistor, causing the servo motors to move. If the photoresistor is blocked, the car will stop.
Well, as for the clock reaction, in this case, or in this experiment, this is presented by a sudden change in color to blue, which in our project is considered a timer to stop the electric minicar. This happens between of two chemical principles which rely on these two equations. The first one, which is the oxidation step, in which ions are oxidized by persulfate to form iodine. However, this is just the first step, and in this step there's still no color change. This happens in the second step, where during the second equation, which is this one, iodine is reduced back into iodide, and thiosulfate is being oxidized to tetrahydrogenate, which leads to the color change trigger, which happens once the thiosulfate is exhausted and iodide accumulates, which in the presence of starch turns dark blue, meaning the end of our clock reaction.
To determine the reagent concentrations needed to achieve the reaction in 80 seconds, we use the data from experiment 3, but adjusting the concentrations of the initial solutions. Then, based on the model that we got, the required ascorbic acid remain concentration should be 0.001 molar, this being 18 milliliters of water in each beaker. And the best data fit is a third-degree polynomial since it's the curve that best describes the behavior of the points in a realistic way. The R-squared of this is 0.9854, meaning it accurately describes the points, resulting in an error of only 1.46%. This graph presents how fast the reaction occurred, considering the ascorbic acid remains over time. And in this case, the regression is almost perfect with a second-degree polynomial having an R-squared of 0.99.
So to sum up everything, we were able to stop our minicar at 80 seconds using the concentration of 18 milliliters of distilled water per beaker, effectively modifying the ascorbic acid concentration and taking into account the external factors such as the temperature and all of the other concentrations, which now we know it affects directly to the reaction's velocity. Thank you.